So now let's talk about specific pattern placement. And there's a whole new set of ways of placing your patterns when you want to do specific patterns. So first there is specific UV space. And this is when you set up a set of flat 2D UVs that correspond to the vertexes of your 3D object, and then use this to project your texture onto that object. So in Max, there is a modifier called the UVW unwrap modifier, and this is where you do all your editing of specific UV space. So you can use stuff like manually hand editing the position of the UVs. You can use tools like pelt mapping, flat mapping, and UV packing. There's also something called auto mapping, which is something that you see, for example, in the software ZBrush, and that's where it takes each and every face, sets up a separate little UV square per face, and then lines them all up in a grid, which is useful when you're doing stuff like baking out various things into UVs. Then there's also a tool called UV Layout, which is a plugin written by Hedis, which a lot of people like using it to do their UV modifications. So it's something you might want to look into, see if it has some tools that you want to use. So the main advantage of using specific UV space over some of the other ways to place patterns on place specific patterns is you have a lot of control over how the UVs are set up. But the main disadvantages is that, first of all, changing the mesh can sometimes mess up your UVs. Second of all, it takes time to set these up, and so it may not be the best method to use if you have like 20,000 objects that you need to shade. And also, sometimes it's hard to visualize where the UV map corresponds to your 3D model. So you have to do a number of 3D test renders to make sure that what you're painting in 2D is exactly where you think it is in 3D. So this is just a very super quick demonstration showing a few techniques for editing UVs. So say you have your object here, and it already has some UVs assigned. You can go to the Unwrap UVW modifier here, and let me show you the UVs on this object. So here are the UVs on this plane, and one of these corresponds to, one of these UVs here corresponds to each one of the vertexes in your object. So to start off, let's see what these UVs look like. And one of the ways you can do that is you can go into your material editor, apply a material, then go under the diffuse channel and put a checker map and set the tiling to a higher value, and then press the show maps in view. So we can see here that there's a bunch of distortion going around on the edges, and that's because these UVs are distorted. Like, for example, you can see if I yank this in or out, you get different kinds of distortion going on here. So one thing that happens quite frequently is you want to take UVs and you want to make them more orderly. And to do that, there's a couple of scripts I use, and one is a Solburn script called the UV Placer. Now, in the UV Placer, this square here represents the same thing as this square here, and then adds a number of tools to very quickly align UVs to various values. So now, U is in this direction, and V is in this direction. So let's start off by taking all of these top UVs, and we want them all to have a V value of 1. So you set it into mode V, and then you press up here in 1, and it snaps all of them up into this area up here. Then we can do the same down here, and then in the U we can grab these guys, put them there, and put these guys over there. And as you can see, this has already really improved the UVs in here, because they're now much straighter on the edges. There is another tool in here called Average, which you can use by grabbing all these guys, say, and it'll take the average of all of these values and then put them at that average. So if I set this to V, and then I hit the average button, it found the average of all of these UVs in the V direction and then put it at that spot, which is another good way to place your UVs in straight lines. And of course you can do the same with U. But even a third way you can change it is, instead of clicking in this outside area, you can click in the inside area. And as you can see, as I click and release on the inside area, it moves the UVs here to wherever I'm clicking inside of this interface. So another tool I use sometimes to edit UVs is called Polyboost. And Polyboost is a plugin that you can go out and buy. However, it's been incorporated into Max 2010. So if you get a copy of Max 2010, all of these tools are now incorporated into the Max base package. So the way this works is, say you have your grid here, and then I'll edit the UVs, and you can see the UVs are really all over the place. And it would take a while to manually place these in a more orderly fashion. It would also take a while if I wanted to go in and use my UV placer script. But Polyboost has a number of really useful features that can speed some of this stuff up. So for example, say I go here and I grab an edge. I can hit the edge loop button in the regular editor and I get the edge loop. But there's no way to get the edge ring, which would be all these guys. However, inside of Polyboost, there is a way to get the edge ring. And you can use this to line sets of UVs up. So for example, say you take the edge ring and then you do the loop. You now have all of the horizontal UVs. And then you can use the lineup tool, which is here. And that lines up all of those UVs so they're now all straight. And then you can do the same with the vertical ones. So you can do a ring and then a loop. So now you got all the vertical ones, and then you can use the vertical lineup tool to do this. Next comes projected UVs. And these are UVs that are projected from a projector source. And frequently this is used along with specific UVs. So you start off by doing the projected UVs onto your object, and then you'll edit the result using the various tools for doing specific UVs. So as far as Max goes, the modifier you use to do this is called the UVW mapping modifier, and it has a bunch of different types of projections, such as planar, cylindrical, spherical, shrink wrap, box, and XYZ to UVW, which, as we discussed before, you use to lock patterns to deforming objects. Now in Max 2009, they added something called spline mapping, although this is something that's existed in a plugin called Texture Layers for a really long time. And personally, I still use the Texture Layers version and not the one inside of Max, and that's mostly because the one inside of Max is not a procedural modifier. So once you map based off your spline, if you then go back in and change your spline, it doesn't automatically go in and update your mapping. So you have to do it all over again. Whereas the one in Texture Layers is procedural, so if you change the position of any of the knots inside of your spline, it automatically updates the mapping. Then Texture Layers also has another type of mapping called FFD mapping, which doesn't exist in regular Max. And what this lets you do is this lets you modify your mapping with an FFD cage, much in the same way as you would use the FFD modifier to make large changes to the vertexes of your object. So Texture Layers is definitely a cool plugin to use, and I recommend taking a peek into it. So the advantages of using projected UVs is, first of all, that changes to your mesh will not mess up your UVs, unlike the specific UVs. And also changing the mapping modifier can affect the UVs on many objects at the same time. So now the disadvantages of projected UVs is that you're limited to certain shapes, like the ones that I mentioned above. And it's also difficult to add an object to an existing projection because of the way the modifier system works. So this is just a really quick demo to show the difference between specific UVs and projected UVs. So say you have your object here, and we have specific UVs set up on the object, which you can see here. Now let's say after you've done the UVs, the director wants you to change the actual mesh. Like for example, maybe you'll have to move a few points, or maybe you'll have to add some extra geometry, like maybe adding an extra set of edges here and move them over there. You'll notice that the pattern on your mesh gets moved around along with your mesh itself. And this may not be what you want. You may want the UVs to still be coming from the top and still be even. So if you, instead of using the unwrap modifier, if you add a UVW mapping modifier here, this is now projecting your UVs down from the top. And now if you go to your edit poly and you turn on show end result, so you can see the result of that modifier up there. Now as you move and change the vertexes or add faces or whatever you do down here, you'll notice that it doesn't change the mapping. The mapping is still always projected from the top, whereas the unwrap UVW specific UVs get moved all around. Now, one more thing I'd like to explain is I mentioned earlier that it's difficult to add an object to a projected UV because of the way the modifier system works, and I'll explain what that means now. So you have this plane, and pretend this plane is actually a whole lot of objects, and you have a planar UVW mapping on there. Now say we add a new object, like a cylinder, and we assign it the same material. Now say the cylinder, we want the cylinder to also have the mapping here. So what I can do is I can go to the UV mapping guy, and I can go copy, and then I can go here, and then I can go paste. And now we have the same UVs that's on the bottom that's on this guy up here. But notice that the two of them are different from each other. So because this object is moved over here, even though we have the same sized projection, it's been moved over. So these two don't perfectly line up with each other. And there are some ways of trying to solve this. Like, for example, you can take this and say acquire, and then acquire from this guy down here, and you can acquire absolute. And then that acquires the absolute position of your projection, and now these two will perfectly match up. But then later on, somebody might say, well, you have to increase the size of your cylinder. And if you increase the size of the cylinder, you can see that its mapping grows with the size of your cylinder. And another possibility is somebody says, hey, so can you change the planar projection down here to something different? And you can do that. But if you do that, it doesn't automatically update the projection up here because these are two completely separate mapping modifiers from each other. So one way you can sort of try to solve that is you can say, okay, well, instead of just copying and pasting normally, I can do copy, and then up here I do a paste, but I do a paste instanced. And now, as I mentioned before, if you change this, you're now going to change the mapping on both of these objects simultaneously. However, as you note again, the two gizmos don't line up perfectly, and the reason is because your two objects are of different scales. So this is just a small sampling of the problems that you get from trying to apply a bunch of objects with the same mapping modifier. And this, it's not too bad if you have all your objects done in the first place, but if you add objects later on after you've already done your mapping, this can be a real pain in the butt. So just a quick word about an issue that will come up if you try using projected UVs along with Turbo Smooth or Mesh Smooth. So you can see I have this object here, and I have a UVW mapping modifier set to box and a checker, so you can see the checker pattern. Now, if you put a Turbo Smooth on top of this, it smooths the edges of your mesh, but the UVs, it totally messes up at the edges here. And this is a very common problem. It's due to a bug in Max, which has been there for years and years. And, you know, one day it might get fixed, but at least until that day comes, there is a pretty straightforward fix. And that is you take your UVW mapping modifier and you place it on top of the Turbo Smooth. And then you get the results that you expect. So there isn't as easy a fix if you're using specific UV space, but if you're using projected UVs, the fix is to make sure that all your mapping happens on top of your Turbo Smooth. And that's something that you're going to see in part 2, because all of my objects will have Turbo Smooth on them, and then I make sure that my mapping is always on top of the Turbo Smooth inside the modifier stack. Okay, so camera mapping is yet another way you can project your textures onto a surface. And what this does is this projects the UVs from the viewpoint of your camera. And inside of Max, there's a map that does this, and it's called the camera map per pixel. Now, the advantages of using camera mapping is, first of all, it's really easy to visualize your detail placement because you're looking through the final camera of your shot and using that to paint from. And it also lets you add detail to only where you need it for your shot because you're seeing everything that your shot sees and then you can paint on top. So the disadvantages are, first of all, if your camera moves around a lot, you need to set up a bunch of different projections to avoid stretching artifacts. Also, in Max, the map aspect ratio is locked to the final aspect ratio of your render. So if you do a bunch of painting using camera mapping and then you need to change the aspect ratio of your final render, it will mess up your projections. Also in Max, you can't use orthographic cameras, only perspective cameras to do camera mapping. So now let's talk about projections. So like projected UVs, projections are similar, but the projection source is decoupled from your object, like it is in camera mapping. So sort of imagine a UVW mapping space warp, where your mapping source exists in the world, and as you move or transform your objects, the projection source does not move along with it like it does with projected UVs. Instead, the projection remains static in your world. So this exists in a number of 3D apps out there, but unfortunately it doesn't exist inside the Max base package, even though it's a really, really useful tool for doing mapping. And one of its big advantages is you can apply it to an ever-changing number of objects really easily. Whereas if you use projected UVs and you want to add a new object to the projection, it's a little more cumbersome trying to copy modifiers around. So the disadvantage is not really a disadvantage with the technique, but it's a disadvantage with the camera map techniques inside of Max, because a camera map is very similar to a projection, except for two things, and those are the two things I mentioned before under the camera mapping section. And that is the camera map is tied to the final aspect ratio of your final render. And for projections, say you had a reasonably square object, you'd want to use a square projection, but you can't do that using the camera map modifier unless your final render is also square. And then also, camera maps don't use orthographic cameras. And usually projections are orthographic and not perspective. So now let's talk about 3D Paint. So this is software that lets you paint directly onto your model in a 3D view. And there's no full-fledged 3D Paint software inside of Max, but there's a lot of plugins that can do it. Like, for example, Body Paint 3D, Deep Paint 3D, although I believe it got discontinued. Mudbox 2 recently added 3D Paint, and other programs like Modo and ZBrush. So the advantage of using 3D Paint is that it's really easy to visualize your detail placement because you're seeing it right there in 3D. And also, it's easy to see the results as you paint them because they appear immediately as you do your brush strokes. There are a bunch of disadvantages. The first one is that using 3D Paint usually requires you to transfer your model into a separate application. And usually there's a lot of things that don't transfer over properly. Like, for example, cameras tend not to transfer over to these other packages. And that can be a disadvantage. So number two is you need to buy and learn a separate application. Next is you probably still need to apply some good UVs to your object, because most 3D Paint programs bake the final painted result into the object's UVs. So even though you're using 3D Paint, you'll probably still have to set up some specific UVs for your object. And next is what you paint in the viewport isn't always 100% what's rendered due to OpenGL limitations. Although this is getting better and better all the time. So these days now, usually what you see in your viewport inside of your 3D Paint package is pretty close to what will be finally rendered. And then finally, most 3D Paint packages are not as full-featured as a 2D Paint program like Photoshop. Okay, Vertex Paint. So this lets you paint directly on your mesh by affecting the vertex color or value of each vertex. And the way you use it is you give the vertex a color, and then you create a vertex map in your material, and then use that as a mask to blend between other maps. So software-wise, you can set up the vertex color inside stuff like the editable poly, the edit mesh modifier, or the vertex paint modifier. Now, the big advantage of using this is it's, first of all, easy to visualize your detail placement. You can see the results as you paint them, which are both similar to 3D Paint. Also, Vertex Paint is built into your 3D app, so you don't have to own or learn a separate application. However, it does have some disadvantages. First of all, if 3D Paint isn't a full-featured paint program, Vertex Paint really isn't. It's usually very, very simple. Some mesh operations can mess up your Vertex Paint. For example, Mesh Smooth, it can make unwanted changes to your vertex map, so you have to be careful about using Mesh Smooth along with a vertex map. And then finally, and this is the biggest disadvantage, is you usually need a lot of geometry, because since you're only affecting the color of each and every vertex, if you want a really detailed vertex map, you're going to need a lot of vertexes. So one thing I use the vertex map for a lot is selecting the edges of things. So basically doing a fake curvature shader. So a lot of effects occur on the edges of real objects. Like for example, paint usually chips off the edges of things. So you see there's some chipped paint, there's some more up here, and there's some more here. So I'm going to show you really quickly how to set up a chip paint shader using vertex colors. So here are two objects, and notice there's a lot of faces here. And what I've done here is I have selected just these edges and turned them black and turned the rest of the objects to be white. Now once I've selected these edges, inside of my material I use something called the warp texture. And what the warp texture does is, it was written by John Burnett, and it takes any map you have and then it distorts it using another map. Like for example, I have the vertex color map here, and then I'm distorting it with some noise. And here's the noise that I'm distorting it with. So the result is that the noise warps the vertex map that was on there to create these sort of noisy patterns. So this is cool, but it doesn't quite look like chip paint yet because it's too blurry. And so what I do is, first of all, I go take my vertex color and I put it inside of an output map. And then I enable the color map and I clamp the vertex color very strongly. Then I go in and I clamp the fractal noise. And then here's the result, which is much more looking like the chip paint I showed you earlier. Then you can use this map in order to blend between two different materials. So here I have my blend, and I have a chrome material here and a paint material in slot 2, and the mask is that warp texture I showed you. And here's the final result. So it's blending between the paint material and a metal material underneath. So I have a script that I wrote that automates the process of selecting corner edges, like in this cube. And the script is called corner edge to vertex map. So what I do is, first of all, I start up here, and there are no border edges in this object, so I don't bother with that. Then it says here select edges by angle 80 and 90, and so what this will do is this will select any edge whose two faces are between an 80 and a 90 degree angle between each other. So for example, this edge here, these two faces are both at a 0 degree angle to each other, so that one won't be selected. But here you have an edge, and this face is at a 90 degree angle to this face, and so this edge will be selected. And then you have some other things you can do down here to apply color, but if I just hit apply, you see that it selected all these edges based off of these angles and made them black and made all the flat areas white. So if you have a really complex model, this is a very quick way to take a whole bunch of objects and select only the sharp edges that go on. And keep in mind that there are a lot of faces in this already. So if you have fewer faces here, the results are not going to look nearly as nice. And that is the main disadvantage of this technique, is you really need to have a lot of geometry in order to get some good results. And finally, let me show you an example of actually using the vertex paint. So say you have your object here, and you apply a vertex paint modifier, and then you can turn on the vertex paint channel over in here. You can now use all of these painting tools to paint your vertex map. So this can be helpful. Say you want to do the chip paint thing that I did before, and you use the script I showed you. So let's just change these values a bit to make sure that we get the edges that we want. Okay, so you can see there we're getting all the edge areas. So say this is what you want, and you're going to use this to do chip paint, but then you want just a little bit of extra areas. Or maybe like this area here that it selected is not an area you want. So one way you can do this is you can grab these vertexes, like here, and in the editable poly you can change its color to white. So that's a way to start with the automated script, but then manually change those. Or another way is you can apply the vertex paint modifier that I showed you before. So let's take color white and let's paint out that area. And then maybe, as well as these edges, you also want some chip paint just in the middle somewhere. So you can go in and paint some extra little areas here and there. And then these areas, once you do the warp texture trick, will also have chip paint on them. So now a brief word about environment mapping. So this is a map that is applied in world space and is generally projected from an infinitely large sphere or cube that surrounds your entire scene. And these are generally used to simulate an environment to appear in reflections. So software-wise, you choose the bitmap map, and then you go up to the top under coordinates, and there's a thing to change to spherical, cylindrical, shrink map, or screen, and that lets you environment map your bitmap in your scene. So the big advantage is it's much faster to use an environment map than to do ray tracing of a real environment in your scene, although obviously the results are not necessarily as good. And then the disadvantage is that this is really only useful for environments and reflections. So there isn't a lot of other applications. Like you generally wouldn't want to use this in a diffuse texture or for your bump map or something like that. And then a quick note, the reason I'm putting this in here as a specific pattern is because frequently when you're using environment map, you want to line it up to the actual environment in your scene or to the lighting in your scene. But you could also consider environment mapping a general pattern placement method if you're using a very generic environment map. So let me quickly explain how to set up an environment map. So we have our objects here, and then we have here a Brazil to advanced material, but the same setup goes for either a mental rays architecture and design material or the ray trace material. So let's take the diffuse color is pretty low. And then down here in the reflectivity slot, I have a fall off, and it's set to Fresnel and given an IOR of 3. Now, this doesn't look very reflective, even though it is, and that's just because it's reflecting this sort of dull gray color in the background. So if we replace that with checkers, we can see that it's reflecting the checkerboard. Now, in the environment slot here, I've placed an HDR image. So what an HDR is it's a high dynamic range image, and this is an image that contains pixel values that are greater than 1. And I'm not going to get into too many details here about what that is, simply because number one, talking about HDR is probably a little more appropriate for a lighting DVD, and number two, it's a pretty involved topic. But later on in the practical portion of this DVD, you'll see me using these again, and I'll talk a bit more about them. Very quickly, though, I'll show you the HDR, and it's just an environment that I photographed outside, and you can see me taking the photo of the environment. So this is set to environ, and then under mapping, I've chosen spherical environment. And so now this is being applied on a giant sphere that is all around your scene. So if I turn this on, you can see we now have the environment in the preview up here. And if we hit render, we can see that the sphere is showing the environment, and it's also showing the reflection of the object below. So the way the environment map works is if you turn on just environment mapped here, it'll only use the environment map and the reflection. And if you turn on ray traced, it'll do ray tracing for any actual objects it sees, like this plane. But anywhere that it doesn't see an object and just sees the background, it will use whatever is stuck into the environment map right here. So now, there's another way to set up an environment map, and that is, say you have hundreds of materials, and you don't want to have to copy this HDR into the environment slot of every single one of your materials. So another way you can do it is turn this off, and then make a giant sphere around your scene. And then take the sphere and put a normal modifier on and say flip normals. And then apply just a standard material, set self-illumination to 100%. And then in the diffuse, place the HDR that we had before. But this time, instead of saying environment spherical, just choose explicit map channel. Because the explicit map channel 1 is just in a spherical environment anyway. So now if we render, we see, even though we don't have an environment map here, it is reflecting the environment, which is on this giant sphere. Now, you'll also notice you can see the environment in the background, and that may not be what you want. You may want it to show up in the reflection, but not actually be in the background, like if you want a composite. So what you would do is you take your big sphere here, and you turn off visible to camera, but you leave on visible to reflection refraction. And now when we render, we can see it in the reflection, but we can't see it in the background, which is much more similar to what you get if you turn on the environment map right here.